Hello everybody, welcome to another tutorial. Today I will be teaching you how to solve projectile motion problems. Okay, to start, let's look at a problem. Let's say a football is kicked with an initial velocity of 20 meters per second at an angle of 60 degrees above the horizontal. Determine the time of flight, the horizontal displacement, and the peak height of the football. Okay, so to start, let's draw a picture. We'll draw the guy kicking the football, and after we draw the football and the flight path, we're also going to label the vector, which is the 20 meters per second and the 60 degrees above the horizontal. Now, to solve a projectile motion problem, you use the same equations you use for any uniform acceleration problem, except there are some slight differences. For one, when labeling down your information, you use two different columns for the x and y components of the object's movement and velocity and acceleration and time. Except for time, there's only one because there's no such thing as horizontal and vertical time. So time will be the same for each, but for each other component, there will be an x and a y. Okay, let's start by looking at what we want to find. We want to determine the time that the ball is in the air, which will just be the normal time, so yeah. And then we want to find the horizontal displacement, which in this case, and any projectile motion case for that matter, it'll be the d of x. That'll be how much the ball travels horizontally, or how much it goes forward from where it started, or backwards. And then we also want to find the peak height of the football, which means how the highest point it possibly gets in its flight path. This is not actually labeled in our columns here, but we'll mark it as dym for the maximum y displacement, which we will solve later. Now, there's a couple things that are given to us at the start of any projectile motion problem that we do. Like, for one, the accelerations of both the x and y components. The x acceleration will always be 0. That's just a given. And for the y acceleration, it's always going to be negative 9.8. Now, in this case, we are given the d of y because we kick it from the ground and it goes up and then it falls back down and it lands on the ground. So the y, it's not going to change at all where it started from, so the y is going to be 0. Now, this is not always going to be true. Sometimes we'll have a problem where something is thrown off the top of a building or something to that effect. But in this case, we have it so the y displacement is 0. And if we have it so the y displacement is 0, that means the velocity final of y is going to equal the negative velocity initial of y. Now we can find the velocities using the vector that is given to us at the beginning of the problem. We know that it says the v initial is 20 meters per second. That's how much the ball is kicked with, or how fast the ball is going initially. And then we have that's kicked 60 degrees above the horizontal. Now, using vector components, we can find the x and y components of the velocity, which if you want to learn more on how to do that, check out my other tutorial, vector components. Now, anyway, so using vector components, we can find that the b initial of x is going to be 20 times the cosine of 60, and the b initial of y is going to be 20 times sine of 60. Now, we know that since the acceleration is 0, that v initial x is going to equal v final x. And we already know that v final y equals negative v initial y. So now we have both the v initial and v final of both of the velocities. Okay, now that we've found everything that was given to us, we are going to start by looking for what we need to solve for. Now we're going to start with time, and we're going to use the equation v final y equals v initial y plus a yt. we're going to be using the y components of the information we have, obviously because of the y subscript. And we're going to solve for t, and we're going to find that t equals 2.04. Moving on, we're going to be solving for d of x now. We're going to use the equation dx equals v initial x times t plus 1/2 axt squared. Going through the same process we just did before, we're going to solve for d displacement of x, which is how much the ball moved horizontally from where it started. And we're going to get that displacement of x is 20.41 meters. Now that we solved for those two, we're now going to be solving for how high the ball makes it off the ground, this maximum flight time. Now, to do this, it's going to be slightly different from what we've done before, since we know, by looking at our picture, we can see that it's like a parabola, and the highest point is right in the middle. So in order to do this, we're going to use the same type of equations that we've been using, and we're going to solve for the dy, but we're only going to use half of t. We're going to be using 1.02 instead of 2.04, using the equation dy equals v initial y t 1/2 t plus 1/2 a t over 2 squared. We'll find that dym equals 12.57. And we're done. That's all you really need to know for solving for a projectile motion problem. You'll find that once you get used to it, it's not really much different from solving for your uniform acceleration problems. Just slightly more work and kind of more difficult, but not that much harder. You'll get used to it and you'll get better. So hopefully you were able to learn something from this. If you weren't, I'm sorry. Bye.